Hey guys, welcome back to the video. And today's video, as you see the title, we are going to make again the model that we will be training using TensorFlow, that is Keras. Alright, so in the last video we have seen how we have detected handwriting using NumPy. Alright, today we will be using TensorFlow, that is one of the most important libraries in machine learning and AI world. So we will be exploring all those, and most importantly we will be looking at how easily you can make a model using those library. Alright, so with that, let's start the video. So first of all, just like that, if you see this, we have to make this network, right? We have to make this deep neural network. So first of all, we need inputs, we need hidden layers. Again, how many hidden layers it depends upon our wish, and then the output. Alright, so let's first make the model and then we will train upon it. So first what we will do, we will try to load this data from Keras. Alright, so it will be given like this. Somewhat some images will be there. We have to detect which particular number it is. Alright, so we will be making this model. Alright, so first of all what we'll do is we will import all the necessary libraries and contents. Alright, so here we are importing TensorFlow, then TensorFlow Keras, layers for importing layers, then Matplotlib we are using for graphical representation, and we are using NumPy for arrays. Alright, after that, the first step, what is the first step? First step is to load the data. Let's load the data from Keras. Alright, so what we'll do is x train, y train, x test, and y test. So we'll be taking two sets of data, that is x train, y train, x test, y test. Alright, from where we will be taking? We'll be taking from Keras dot datasets dot MNIST dot load data. Okay, so we are first loading the data. Let's check it whether any error is there. Okay, no error. So let's move to the next step. So after loading, what is the next step? The next step is to normalize and flatten. Alright, as we have seen in the last video. If you haven't checked out the last video, I recommend you to check out the last video so that you have the deep understanding of how we have used the NumPy and how we are building the model. That will be giving you in-depth knowledge of how the raw data comes and how we make the raw model. Alright, so here we are using some libraries that are already there in the Python for you to, it is easier for you to write a program. Alright, so once we have taken the loaded the data, what we will do is x train will be taking and x test will be taking. Now what we will do is x train and x data will be x dot train. Let's normalize it. X train dot reshape. We have to reshape it. Alright, so let me just, okay, x train reshape by what? Reshape minus 1, that is one dimensional, 784 is the size. Alright, divided by 255.0. Why we are dividing? So that it gets lower, the value we have to lower it. Alright, and for x test also, x test also dot reshape, like this we have normalized and flatten it. Okay, I hope you are clear with this. This is same for the last video also. Next, now we have to build a model. Alright, now we have to build a network, neural network using Keras. Observe this particular function. So first of all, we will make the model. How we will be making the model? From, okay, so it is there already. So it is a very convenient for you to make this, because already Google Colab will be suggesting you some codes. You just need to understand it. Alright, so observe here model we are making. Alright, model is a variable. In that, TF is a object. That object we are calling Keras library, we are calling sequential. This sequential is will make us layers. Alright, so in this layer we will be defining how many layers we need. So here we are defining, see, in the third bracket we are defining 3 layers are there. Alright, earlier we have made 2 layers, this time we will be making 3 layers. So first layer is hidden layer. I'm talking about first layer is 128 size. Okay, 128 hidden layers will be there. Next size will be 64, hidden layer will be there, and then last one will be 10. As of we need the output as 10, 0 to 9, the size is 10. So middle size is 128, the next one will be size is 64. Alright, this you need to understand. So here we are using ReLU for the first activation, second activation also ReLU, third activation is softmax. Okay, just to predict the possibilities, probability of all the numbers. Alright, we are using softmax. Next, after this we have created that model. Alright, this model activation function we have called, and we have built the architecture. Next, what we will do is we'll build this architecture. How many layers are there, how many hidden size and all, we will have to pass it. Okay, this is just a model that we have made. So now let us pass that model. So what we have to do is we have to compile that model. Model dot compile, model dot compile. So observe the code. So first of all, we have to model compiler with optimizer. Optimizer is what? Adam optimizer, for it is used for fast conversions. We want fast conversions, so we'll be using optimizer Adam. Alright, it is a keyword that you need to use. Loss will be using sparse categorical cross entropy. Alright, this is also a keyword that you need to use. Alright, it is already there, you are just using it. Alright, next, matrix equal to, what matrix you want? You want accuracy. So you'll be writing accuracy. Alright, this is how you need to define what kind of model you want to compile. Alright, so this is very important in Keras. First of all, you define the model, how many hidden layers you want. Earlier you were making all the model using NumPy, the mathematical formula. Here no mathematical formula, just kind of function calling and just define the size, that's all. Alright, so model you have defined, model you are compiling. Next, what you will be doing? You have to train the model. Alright, data you already have, so you have to train the model. But till now, are we making any mistake? Let's see. Okay, till now no mistake. So let's go on. So I am creating a model. We have to do model dot fit to train the model. Alright, so we are training the model. So here again they are suggesting, let's see it. So X train is there, Y train is there. So this is the training inputs are there that we will be using. Alright, once we have used this, we have to put epochs. Epochs How many epochs are there? There are 10 epochs we are using. I already told you last class, epochs is nothing but how many times you want to run. Each epoch will be again having interval, how many interval you want to have. So each, how many epochs? Here 10 epochs I want. Number of training passes over the data, how many times you want to train the data. Alright, now first I have to give batch size. What is the batch size? It is 32. Alright, after defining the batch size, what we have to give is validation split. What do you mean by validation split? It is simple that we are using 0.1, that is 10% we are using as training purpose. Alright, 10% of data will be using as training purpose. Next, verbose, we have to show it as 1. We are keeping it true. What do you mean by that? It means simply that while running the program, it will display the progress. Alright, so this is what history model we are training. Alright, history is a variable where we are training the model. Alright, as we run, you can see the epochs here. Already it is progressing, and you can see here the accuracy and loss. Alright, so we have done already training, but here what I like to do is I would like to add the graphical representation. Let's add that also. Alright, so here I am adding graphical representation. These are very simple, it's just that we are printing the graphical representation. Now let's run that. So you can see here it is running. We have to wait for some time. It will run 10 epochs. Alright, 10 interval it will run. So you can see here one thing, accuracy and loss. Alright, so as accuracy increases, the loss will decrease. So that's it. So yeah, if you compare to the last video that is using NumPy with it is very simple, because TensorFlow is providing the library where we can directly call it without using those complex formulas. Alright, so this is one way with which you can build your own model or train your own model. So here you can see the accuracy level, it already reached 99. Let's wait for some time. Epoch 8, epoch 9 and epoch 10. After that we'll be seeing a graphical representation also. That's the whole point of me printing it out there. So epoch 9, epoch 10, you can see 99.646. Alright, so here you see model accuracy and model loss. Alright, so as you see, the more epochs is going on, more accuracy it is gaining, and now loss is decreasing. Alright, so with this we have completed this particular video. I hope you have understood. I will be pasting the code down in the description. You can download it from there. Alright, and thank you guys for supporting in the last video, and I hope you guys are enjoying it. I will be continuing with more of cybersecurity videos and AI videos parallelly. So keep supporting me. That's it. Thank you.